Explain.
All right, we'll try to do the short version.
Matter into energy.
All right. Yes, it's made by splitting atoms. So.
How do you do that?
How come?
Okay.
I know, but like how?
Let's talk about how the actual splitting works and then the actual structure of an atomic bomb. If anyone, needs to make one. So, we have
We're good.
I need to have a material list.
plutonium right here. Okay? We use uranium to make plutonium. We actually force it to take on another 2 protons. Okay? Making it into plutonium. It's got 94 protons. Means they are already barely hanging on. Because remember, protons are the big sweaty football players. Right? They do not smell good and want to stay away from each other. It's also true. Okay, protons also do not like to be together, but they are held together by what is called the strong nuclear force. It is the strongest of the forces because it forces them together. However, it loses strength very quickly as distance grows. Kind of like a magnet, right? It's very strong up close, but as you pull it away, that force just dissipates. Same thing. So, when it's like, 2 protons, that force is unbreakable. Absolutely. Okay, not going to happen. You're not going to get those 2 protons apart because the strong nuclear force is so incredibly strong. However, by the time we get up to 94 protons, all being held together, it starts to get a little bit shaky. It's barely holding on. Then we start adding neutrons. Now, neutrons, they don't care. Okay, they're not reacting to the protons. They're not reacting to the electrons. They're not pushed around. They are more like, so if the protons are big sweaty football players all trying to stay away from each other, being held together by the strong force, neutrons are kind of like the jerk neighbor kid, just kind of like, hey girl, what's going on? And just go stand in the middle
Just
of them.
stop. Just go get a packer.
And they keep throwing more and more of these derps in. Okay? They just pack them in like they're overfilling a balloon. Derps, yes. What? Yes. We're calling neutrons derps. Okay? They're not positive, they're not negative, they just kind of wander in and fill up space. And so you start packing more and more and more neutrons into this already unstable, barely holding together. We just pack neutrons in there until it's just like a tight balloon. And then, when we have it there, we have an explosion. And this is where we have the actual structure of an atomic bomb. It is a simultaneous, omnidirectional explosion inward. Okay, so we get regular explosives and we explode them all around here, all exploding inward at the same time. Which then gets this big old balloon and puts a lot of pressure on it, and it will actually split. And what they had to work on was the chain reaction. So it splits, all those derp neutrons go wandering off, they hit into the next one, explode that balloon, explodes the next balloon, next balloon, next balloon, and you end up with this chain reaction. Now all this happens in like 1/1,000,000th of a second, but it is the first balloon popping the next one, popping the next one, popping the next one, until they've all reacted in this much space, all split, and now they have to take up like a city's worth of space with all this energy, and it just...
Yeah, how far does it take for like an atomic bomb to like
Like after it explodes, how long or far does it take for it to actually just like dissipate?
Okay. That depends on the power of the atomic bomb and its atomic makeup. The first atomic bombs that we actually know, we could see those in real life. That was Hiroshima and Nagasaki.
Sit down.
If you ever want to you're sick of your old nightmares and you want new ones, read a book called Hiroshima. Okay, real life accounts of the victims at Hiroshima. I will avoid telling you those stories, but it's worth some new nightmares.
Why doesn't an atomic bomb ever stop? Why wouldn't it just keep going forever?
Oh, because as soon as it goes, and by the way, they were worried about that. There were people who were worried that if they set off an atomic bomb, it would just continue that chain reaction and ignite the entire atmosphere. That essentially it would set off one and it would blow up the whole world. Yep. Straight up Alderaan style. Right? Alderaan. Anyway. Luckily that did not happen. If any of you were taking notes, the world did not end on that day in 1945. Okay. Because this chain reaction only works when they're right next to each other, the balloons popping, setting off the next one, which are already all crammed together. As soon as that energy starts to push them out, the reaction stops. This balloon pops, but there's nothing right next to it to pop, and the chain reaction ends.
Wait, so what?
No, you don't need it. You can take it out.
Okay. This chain reaction is reliant upon all of them being really, really, really close together.
All the atoms?
All the atoms, yes, the ones we're splitting. So, this one pops, it sets off these ones sets off these ones. However, now the explosion's already started and already expanding outward, pushing these ones on the outside out. So by the time they're out here, this one splits, but it's got nothing around it. And so the chain reaction fizzles.
But that sounds like it wouldn't be that big of a bomb if it's just kind of like...
Until you understand how much energy is created just in these splits. E equals mc squared, right? Energy equals mass times the speed of light squared. So when we are changing mass to energy, it's not, oh, this much mass turns into this much energy. We first take the mass and multiply it by the speed of light squared. These are really big numbers. Really big numbers. Okay? So, even though a little bit of mass was lost here, the amount of energy created, well, speaks for itself. Mushroom clouds, leveled cities, end of world kind of stuff. Yeah. All dead stuff. Anyway. Is there something else I was going to say? Do I go with them? It's like a whole bunch of charges all meant to go up. They've got a core, which is often just like a pellet of enriched plutonium. And then they've got these, it'll look almost like a ball. But what it is all these focus explosions all hitting inward at the same time, meant to start this chain reaction, and that'll blow up. Then they sometimes use those to start a fusion reaction, which is just even more energy. But yeah, part of the problem with a nuclear weapon is this chain reaction is not perfect. So a lot of times, a lot of fuel just gets blown up, right? Scattered out, and all this is radioactive, which spreads radioactivity all over the whole area, which makes the area largely unlivable for a very long amount of time.
It's okay.
Genius who was, I don't think he was evil, but he was probably very cold, like he was just thinking about the science, proposed the idea of adding cobalt with 2 nuclear weapons, which I said, I don't think he was evil, but if you think about just introducing that knowledge into the world is horrifying. Okay, this radiation will go out, but it's a very unstable kind of radiation. Plutonium is a very unstable kind of radiation, and it will actually, it will dissipate, right? It will become less and less radioactive. The addition of cobalt makes what they called a dirty bomb. Okay? Where the cobalt would essentially store, amplify, and release the radiation over a period of 50 to 100 years. So essentially you have a nuclear bomb that not only wiped out an area, but made it deadly to all living things for nearly a century.
So it wipes out and poisons it?
It's actually, luckily, as far as any of us know, no one has ever actually been stupid enough to make one of these. A nuclear bomb with cobalt in it. But it's horrifying that it is known that you could make one of these. Where, yeah, you would